If you know what a graph looks like, especially if it has symmetry, that can be really helpful in trying to determine what a definite integral might be. So first off, if f is an odd function, definition of an odd function is that f of negative x is equal to negative f of x. That means that the function would have origin symmetry. So whatever takes place on one side, we'll see a mirror image through the origin. Now suppose that I'm interested in finding a definite integral from negative a value to positive the same value. Through the use of symmetry, it's relatively straightforward to show that all of the positive area that we get on one side will match the negative area that we would get on the other side. So if we're taking the definite integral from negative a to positive a of f of x dx, this is going to wind up being equal to 0 because the sum of the signed area is going to cancel out. On the other hand, if f is even, the definition of an even function is that f of negative x is equal to f of x. This means that the function would have y-axis symmetry. So whatever we see on one side of the graph, we see the mirror image on the other side. In the event that we have a similar integral to the one that we saw before, this time the areas on either side of the y-axis are once again equal in magnitude, but now they would either both be positive or both be negative depending on whether it's above or below the axis. So in the event that you see the definite integral from negative a to positive a of f of x dx, you could simply calculate half of this area and double the result. Now that 2, because it's a constant multiple, can go on the inside of the integral or on the outside of the integral with no penalty. As a quick example, if we were to consider the definite integral from negative pi over 2 to positive pi over 2 of x squared times the sine of x. Technically, this can be done using a technique of integration we've not yet talked about, referred to as integration by parts. But please note that if you were to take f of x to be the function x squared times the sine of x, then f of negative x would be equal to negative x quantity squared times the sine of negative x. Now the negative x quantity squared will become positive x squared. But sine is an odd function, so the sine of negative x will be the negative sine of x. Please note that the result that we get is exactly negative f of x. That means we have a situation of an odd function which has origin symmetry. Because the graph is going to go from negative a value to positive the same value, it becomes quite apparent that this is going to wind up being equal to 0. Now, just for a little bit of clarity, let's take a look at the actual function itself. So x squared times the sine of x. I'm going to alter my window so that we can see what's going on with this. I'm also going to check to make sure that I'm in radian mode and not in degree mode. So setting my window appropriately, let's go from negative 2 to positive 2 in the x direction, and in the y direction we'll go from negative 4 to positive 4. We should be dealing with relatively small values. As you can see, the graph does, in fact, have origin symmetry, and if you're interested in getting an even more accurate result, we can ask the calculator to calculate a definite integral for us. Now, you can either arrow over to the appropriate value, or simply type it in yourself. So from negative pi over 2 to positive pi over 2, this would be the area that we're calculating. Notice that the calculator has decided that that area is in fact equal to 0 due to the lovely symmetry that we have associated with this. Didn't need to integrate, didn't need to find an antiderivative, just interpreted the function as being odd.